Welcome, everyone. We're going to talk about chip number 52, partial offers from Yak. Yak, I don't think needs any introduction in this community, so go ahead and take it away.
Thank you. Yeah. So when we think about offers, um, they're kind of simple yet very powerful primitives. Basically, the concept they're based on is that you can have a puzzle and then make an assertion that some asset goes to one of your addresses. And it really enables offers. And as we've seen in the past, they're very flexible. You can trade a bunch of assets on both sides. You can have royalties. You can do NFTs. You can really trade all kinds of assets. Um, and this flexibility has helped decentralized applications a lot as well. However, when you look closely at fungible asset trades, offers have some kind of inefficiency. And this is what CHIP-52 is about. It's trying to fill in kind of a small void. The problem I'm talking about is order matching. So if you want to buy two Marmot coins for, let's say, 2000 XCH, then someone having only one Marmot coin that they want to sell, they can't use your offer for anything. You either have to do two offers to buy one Marmot coin each, or they can't accept. Um, this, in the context of asset trades, makes matching very inefficient, and prevents Chia from having kind of the order book-like experience that we would ideally have. So partial offers are a puzzle that's a bit more complex and more specialized than offers, that tries to preserve the nice features of offers, such as that you can create them off-chain and the transaction only goes on-chain when someone accepts them, um, while adding the option to partially fill the order. And that way you also solve the matching problem. So again, the distinction is really that offers are more general, but they don't give as much flexibility when it comes to fungible assets. Meanwhile, partial offers are restricted to fungible assets, and the current puzzle is just one fungible asset for another, but they offer that flexibility when you feel you can only fill 10% of it. Um, in terms of implementation, there is a short chalice puzzle. It's been really optimized. When you are thinking about offers, the more partial offers you can fit into a block, the more trades you can have, and that I think correlates with market efficiency. So there's been a lot of effort put into drafting different versions of this partial offer puzzle and choosing the one uh, that's most efficient. And in this context, it means the less cost. Uh, this is a repository that contains a CLI, so you can fire up your Sage wallet on testnet. You can pull this repository and play with partial offers today. It also includes tests for all kind of pairs you can do with the fungible assets we have on Chia today, and namely, we have Chia, we have cats, and revocable cats. In terms of security, besides the usual puzzle risk that comes with any Chia puzzle really, um, the concern is that if you give people the ability to fill an offer, they might do so with very small amounts in an attempt to do the equivalent of a dust attack to your address. And partial offers have kind of two ways to prevent that. First, they can impose a minimum fee that needs to be paid for every transaction. So if someone wants to accept your partial offer 100,000 times, then they have to pay that minimum fee in Chia 100,000 times. The other protection is that when you create a partial offer, you can set a minimum amount required to accept. So if you make a partial offer uh, wanting to, say, buy 100,000 space bucks, you can set a minimum amount of 100 space bucks. And then someone that attempts to spam you with 0.001 space bucks, they can't accept your partial offer. Something I did forget to mention is that for partial offers, um, when someone partially accepts, the remainder of the offer is automatically recreated on chain. Since someone can go on and fill your offer more after that first offer acceptance. This is done on chain by the puzzle. So things like bulletin boards or wallets can track it and can calculate the new partial offer string from the other one. These partial offers, they are shareable via string like normal offers. And actually the strings, at least for acceptances after the first one, will be much shorter because they have a special memo format that allows the wallets to reconstruct the information about the coin more efficiently. I think that's pretty much all from me. I'll open it for questions.
I have one question. When you create the new partial offer coin, is it hinted to the wallet address of the wallet that created the partial offer? That way it can find the new coin and update its own state about the offer and resync it if needed.
This brings me back to one of the other nice optimizations. The puzzle is made so the puzzle hash remains constant. So you can always query by puzzle hash. And that way you don't only get the latest unspent coin, but you can also get the full partial offer history.
So if you create a partial offer in your wallet, then your wallet would be subscribing to the puzzle hash and looking for future coins that are or coins that are spent with that puzzle hash then.
Yes, exactly. And if someone tries to create coins with that puzzle hash in an attempt to spam, they would basically be creating partial offers to you.
But what if you resync your wallet and
Then you'd run into a similar problem that you run with normal offers as well, which is you lose data. So you'd probably have to back them up.
So you could like export the partial string just like you do with a regular offer.
Yes. Another detail, partial offers are cancelable on chain. So because of the way the puzzle is structured, you have a lightweight inner puzzle, and in between the inner puzzle and the cat outer layer, you can have pretty much any layer. So for revocations, we basically use a one of n, where one of the puzzles you can run is the partial offer, and the other one is the custody puzzle of the maker. And that way you can spend partial offer coins as they were yours, and you do that in the events you cancel. This is very neat when you combine the functionality for, say, in a market maker context, because you can have an expiring partial offer, and then let's say 3 people fill the partial offer, so you have the partial coin. You don't need to make an on-chain transaction to cancel it. You can just generate a new partial offer based on that latest coin that's on chain, knowing that the first path is not spendable thanks to expiration. I should also add that there's been kind of a review from Quax, who is from CNI. He's been kind enough to review the puzzles and leave some comments. So our whole conversation is documented in this issues tab here, with some concerns that remained unresolved, as well as the reason, of why these concerns were not kind of resolved. They were addressed. There's a lot of choices to make in the architecture, and if you want to dive into why partial offers work the way they do, this is a big part of it. And then the chip already has some comments from Jude, who's here, and you can see the answers in the thread as well. And this first comment just documents the costs for the scenarios I talked about earlier. The tests are done with kind of a class that's called benchmarkers. So these tables record the costs generating during the test. And this include both buy costs and execution costs. So they are a very good measure of the cost of an actual transaction in a scenario where you have no block compression.
And it looks like the costs are pretty reasonable given what you're doing.
Yes, you'd expect them to go higher when you use cats or revocable cats because those have extra layers that add complexity. But overall, I think they are very close with the cost of a normal offer, which is very good.
Yeah, that's great. And I guess that was the main reason why you kept it to just one for one pairs instead of allowing more than one on one side or the other.
Yes, allowing more. This is again documented in the GitHub discussion. Allowing more on either side complicates the puzzle, and that that would mean that even though partial offers will probably mostly be used for one-to-one asset trades, uh, if the puzzle is not specialized, it would still contain that logic. So it would increase its size a lot. The partial offer puzzle is 438 bytes long right now. So the reasoning here is that should there be a need for multiple assets on each side, you can have another puzzle that's maybe a little bit bigger but allows you that flexibility. And this keeps being specialized, which allows the maximum number of one-to-one offers in a block.
Yeah, that reminds me of in the MIPS chip, there's an M of N puzzle, but then there's specialized like 1 of N and M of N or N of N puzzles that are more specific but more optimized.
Yeah, it seems like the one limitation of this is we need better RBF, which is out of your hands, obviously, but um, it's going to be hard for more than one person to take an offer, a partial offer in the same block because we don't have RBF. Is that right?
Yes, and RBF logic is having it implemented it 2 times, almost 3 now. It's pretty tricky to implement, and the fees increase very fast from replacement to replacement. So the most it can do, even if it's properly implemented, is go from I can do one transaction per block to go to I can do a few transactions per block. And I think the short-term solution in this will be aggregators. So you can accept partial offers with an offer. You know how in order to accept an offer, you basically generate a counter offer and then you combine them. Well, if you have a partial offer and you want to accept 10% of it, you can create an offer and combine that. So if you put an aggregator in the middle, and the aggregator could go through a lot of trading paths, so it could look at partial offers, normal offers, and AMMs. Then the aggregator would be the one that would worry about RBF and maybe combining your offers with some other users' offers. And I think that's how you get more throughput. But if you want to keep it strictly peer-to-peer, then indeed partial offers will have at most a few transactions per block. And if you are, say, a market maker, I would strongly consider having maybe more than one partial offer at a time, even though they are partially fillable. Having, say, 8 open partial offers at the same price gives you an ability to parallelize them.
Yeah, makes sense. Are there further questions right now? Hmm, sounds like no.
I have one. Is this the shortest chip call?
It might be. It's it's got to be pretty close. We can keep it going a little bit longer. Um, do you have this actually implemented anywhere and running?
Yes, in the CLI that's linked in the repository, and yes, it's here. So you can download it and you can run commands to generate offers, accept them, cancel them, and view them.
Oh, okay. I assume we'll see this on Dexy pretty soon and on Sage.
That's
We'll have to port
that's
it
not
in,
a question for me,
Not a question for you,
Brandon.
no.
port it in Sage once it's been reviewed by Brandy and so on.
Yeah. Yeah, it's a great concept. I think everyone's all in favor of it. So we just gotta make sure we get enough reviews in and test it out. And probably pretty soon we could move it into review.
Sound good?
Yeah, so anybody else have questions? Last chance.
No, thank you for taking the time today, Ek. Excited for some partial offers.
Thank you for coming. Highly appreciated.